All right. Well, thank you for having us here. It's exciting to be here to share our work. My job here is to set the stage up and then introduce our star recent graduate student who's going to join JP Morgan next month. And this is the last project he worked on with us, so I'm very proud of what he has been able to do. So I'd like to recognize my colleagues, Urban Ide, he's co-PI together with me, and then Mike Fisher, he's a former CTO of Etsy. He's our double alum. He has been working with us as a technical advisor. Also, our wonderful collaborators from University of Pittsburgh, Ali is here, Morgan Frank, faculty member at University of Pittsburgh, and Sarah Bana, Chapman University. So these are our team collaborators. Very briefly, the project that we worked on is a part of a larger project that we are doing, responsible digital innovation in the LER space. We just completed a report, a fairly comprehensive report on the design patterns and principles of responsible universal LER ecosystem. For those who are interested in reading the report, I'll be happy to share the report with you via email. As part of this project, we thought that it would be useful to demonstrate the capability, leveraging the large language model that our collaborators have built, automatically issuing W3C compliant, verifiable micro-credentials, turning a single credential at the transcript and diploma level into a series of micro-credentials that our former student has accomplished. So it has several key components. The first one is ingesting the unstructured PDF form transcript, turning into a series of identifying courses and grades, and then we pull down the syllabi of the courses that are included in the transcript. Then using the large language model to extract the skill vector with the weight of the student, and then using our heuristic algorithm to identify or infer the skill sets that the student might have accomplished during that program. And then we use Velocity Network's credential engine to produce verifiable credentials and then issue them into their wallet. So I'm going to turn it over to first the video created by Ali. You're going to hear his voice. He's here in the room. And then after that, Ishan will take over and then explain our heuristic algorithm and then show you the demo video to conclude the presentation.
In this work, we developed the syllabus to ONET pipeline as a framework that enables policymakers and decision makers to extract ONET skills from course syllabi. This work is a collaboration between the University of Pittsburgh, Chapman University, and Teachers College, Columbia University. In order to investigate how college education prepares the students for the labor market, we developed a framework to extract the skills being taught at higher education institutions using their curriculum and map them to work activities required by the labor market. The framework receives a raw syllabus as input and breaks it into sentences to keep only the course description-related sentences for the next steps. Then, the framework utilizes language models to compare the semantic information in a course description to the semantic information encoded in the skill taxonomy. It is worth mentioning that in this work, we use the ONET detailed work activities as the skill taxonomy, which can be replaced by other skill taxonomies to meet a specific domain's needs. Finally, the framework calculates the pairwise similarity between each sentence and a skill and aggregates the scores for each skill across different sentences. As a result, a raw course syllabus is transformed into a vector representing its similarity scores with each of the skills.
All right, so in essence, what happens is when we take in a student transcript in the PDF format, it goes through our large language model, which we have in our backend, takes in the course syllabi, which we also have in our backend, and kind of gives us a vector of the skills along with this course, which we have that if you took this course, out of these skills, these are the top skills you're likely to have achieved after completing this course. But as a student, you don't take just one course, you take a lot of courses, I don't know, probably hundreds of courses. They are like on different levels, different course credits, different grades. And each course reinforces somewhat what you learned in the past courses. So how do you kind of aggregate all of these factors and give that, hey, you completed these 10 courses out of your undergrad degree. This is after completing all these courses, these are the skills which you are most likely to have achieved. So there are a lot of factors which go into that play, but some of the factors which we considered for our purposes was the course credits, like if you take like 3.0 or 4.0 course, that's a factor which we considered. What's the grade you achieved? And one other factor which we also considered was how a future course reinforces the skills you achieved by completing the past courses. For example, you took CS courses, 10 CS courses, and you took just 2 maths courses. Then you're more likely to be good at technical skills like Java or Python as compared to calculus or statistics. So considering this heuristic algorithm, what happens is we take that the score vector, multiply it with our course credit. That's our first step to consider the course credit for each of the courses. And then we include the grade factor, which is also available on my screen, which is if you took an A grade, if you got an A grade, this is the multiplication factor in B, C, and D. So that kind of reinforces that depending upon your performances for the grade for the course, this is the level of the skills you achieve. And finally, we aggregate the sum of all these skill vectors for all of those individual courses together, which kind of brings me to my same point which I was making earlier, that reinforcing how the past courses and the new courses you're taking aggregates and reinforces your skill learning through your undergrad or whatever degree you're taking it. So this is kind of the heuristic algorithm we take, some of the factors which we considered. There are a lot of more factors outside of this vector, but kind of this gives an idea that using this heuristic algorithm, we can go down that after you took this level of courses and the course syllabi which is in there, our large language model is able to provide the skill vectors for us, and then finally a curated list of the skills based upon this heuristic algorithm. So now I'm going to head over to our demo, which is how this entire thing comes into the play for our application.
Hi, everyone. Welcome to the demo of Skill Certify AI. I'm Ishan Gupta, project lead for this amazing innovative solution by Case Western Reserve University. Skill Certify AI leverages a natural language processing framework model in its backend, along with a blockchain-based utility layer to help map course syllabi into skill competencies for students and then generate micro-credentials recognizing those skills achieved. So let's see how this goes. The first step is the account registration by the students, where they use their email address provided by university and upload their unofficial student transcript. The next step is the student gets to review the list of all the courses they completed as well as the grades they accomplished for them. Moreover, the students can review the syllabus for all the courses they took and completed as part of their academic journey. Thirdly, using a natural language processing model, the students can review the list of achievable skills for all those individual courses they accomplished as part of their academic journey. Once that's done, the students get to see a curated list of all the skills they might have accomplished by completing the list of all the courses they completed as part of their academic journey. This is done using a heuristic algorithm, which I'll talk later in this video. But once the students can see that curated list, the students can self-validate, claiming whether they actually feel they have accomplished those skills or not. After this self-validation step, the students can finally generate blockchain anchor digital credentials for all those individual self-validated skills and can share those credentials with anyone who they feel like. So let's see how this goes. The first step is account registration. So I'm going to put in my name, my email address, my username, my password, and do my account registration. Once that's done, it asks me to pick the choice of my degree. Since I was an undergrad student, I'm going to choose undergrad. And now it asks me to upload my student transcript. I already have my university student transcript in its PDF format with all the academic courses with their grades listed over here. So I'm going to upload that right over here. So choose file. Where is my transcript? Transcript, and upload my transcript over here. And then click on Academic Progress. This initiates a data pipeline process for where the data from the transcript is extracted and loaded into our SQLite server in the backend. Once that's done, the students can review the list of all the academic courses they completed along with the grades over here. They can also see the syllabus for all the courses they took at their academic institution. So once that's done, I'm going to click on Review Academic Progress. This is going to pass in all the course syllabi into a natural language processing model, which generates the scores for all the possible skills the student might have achieved. So over here, you can see that if I took an econ course based upon the course syllabi, the list of achievable skills for this course is going to include estimation cost of goods and services, determining pricing or monetary policies, calculating costs of goods and services, and all those skills like that. What if I took a computer security course? For a computer security course, I'm probably going to achieve skills in analysis, security of systems, network, or data, implement security measures for computer or information systems, monitor the security of digital information, and all those skills. What if I took another or probably CS course, let's say 345? So for a program language concepts class, these are the list of skills which I might have achieved. So these are the individual set of skills I might have achieved by completing these individual courses. But now I'm more interested in a curated list of skills I have achieved by completing all these courses at my academic institution. So for that, I'm going to click over here. This initiates the heuristic algorithm microservice on our backend, which takes in all these scores for all these individual skills and then consider factors such as grades for the courses I accomplished, the course credit for each courses, and another critical factor this algorithm takes in is the number of occurrence of the skill across multiple courses. What I mean by that is, let's say a skill has a high score across 7 different courses, then that skill is likely to be achieved by me as compared to a skill which had a high score across just 3 courses. So that the larger the overlap the skill has, the higher the chances it has been achieved by me. So consider that heuristic algorithm. This is the list of skills which I might have accomplished after completing all those courses. Over here, it lists top 20 skills. 20 is a hyperparameter that could be tuned depending upon the needs of this application. But at this step, the students are asked to self-validate whether they actually achieved these skills, if they believe they achieved these skills or not. So since I took a lot of security courses, I believe I have achieved this skill. Since I took a lot of projects and developed reports, I think I have achieved this skill as well. Given I've taken 3rd level of calculus course, I'm pretty sure I'm good with statistics and mathematical courses. Since I've taken a lot of technology-based courses, I'm going to go with this skill as well. So I can validate all of those skills, but for now, for the demo purposes, I'm just going to pick the top 4, which I feel I have accomplished. So once I'm done, I click on Validate Skills and initiate the generation of micro-credentials for these 4 skills. So this hits our microservice in the backend, which takes in all these self-validated skills and starts generating micro-credentials for that. Just give it a minute. It takes a few minutes before it starts the process. Yep, there we go. Our certificates are generated. A JSON file is also generated, which shows the information about the vendor user ID, vendor endpoint, and all the information regarding which might be concerned as per our certificate issuer. What is important for the students is this QR code, which is generated, which the students can scan using this Velocity Network Foundation app and can download and claim all the micro-credentials which were generated after the last step. So this is how the entire application flows, starting from the university student transcript in a PDF format to finally blockchain anchor digital credentials in JSON format. We saw this from the undergraduate student persona. I have another persona prepared for us just to demonstrate how
All right, so that was part of our demo. Now I'm going to hand over to Professor Yu, and he's going to be there.
All right. Well, that was pretty awesome, and we are very happy that we were able to demonstrate the capability. The next step is the skill sets that we are relying on is O-Net skill set, but we are working with our partners to expand those skill sets from other databases as well. And we are trying to use this technology to apply in certain industry sectors. So thank you for your attention. Thanks.